Hello everyone and welcome back to the Intermediate Algebra video lectures. Today we are going to be covering how to multiply polynomials together. So before we get into multiplying polynomials together, we're going to recap how the distributive property works, because the distributive property is going to be essential to the process of multiplying two polynomials together. So when you have some sort of polynomial that is in parentheses, and that is being multiplied by some either constant or variable or constant and a variable, what you do is you multiply what is being multiplied to the parentheses to every single term in the parentheses. So we're going to distribute this 2 by taking every single term in the parentheses and multiplying them all by 2. So 2 times 4x will give us 8x, and then 2 times 5 will give us positive 10. Now, when you are just multiplying a constant by some sort of monomial term, all you do is multiply the coefficients and leave the variables alone. The only time that you change any powers on variables is when you multiply variables together, which we will get into shortly. Now, it also doesn't matter the order for multiplication, because multiplication, the order doesn't matter. So the constant that's being multiplied by the parentheses can either come before the parentheses, like in this example, or it could come after the parentheses, like in this example. So what you would do here is, because the 4 is being multiplied by this parenthesis, you would distribute the 4 to every single term in the parentheses. So 4 times negative 3n would give us negative 12n, and then 4 times 2 would give us positive 8. So it really doesn't matter the order in which the multiplication occurs. Now for this next one, because a number always takes the sign to its left, this 5 is negative, so we're going to distribute a negative 5 to every single term in the parentheses. So negative 5 times 1a is negative 5a, and then negative 5 times negative 1 is positive 5. And then we're going to do the same thing for the last one. So 6 times this polynomial, we're going to distribute the 6 to every single term in the parentheses. So 6 times negative 3x is negative 18x. And then positive 6 times negative 5 is negative 30. So also, as a quick recap, there is a reason that we started this chapter with rules for exponents. So when you multiply polynomials, what is going to happen is you're going to have a lot of variables that are being multiplied together. And if you were multiplying two variables together and those variables are the same, you can combine them by adding their exponents using the product rule for exponents. So remember, if you have x to the power a times x to the power b, that is going to be x to the power of a plus b according to the product rule for exponents. So basically, if you have two exponential expressions with the same base and you are multiplying them together, you're going to simplify it by adding their exponents. So that is how you multiply monomials together, when you multiply a term that has a variable with another term that has a variable. So if you are multiplying single terms together, what you will do is you will multiply their coefficients, and then if the variables are the same, you will multiply the variables and combine them using the product rule for exponents. So if you're multiplying an x by another x, what you will do is you will add the exponents together, basically using the product rule for exponents. So what we're going to do is we're going to multiply negative 2x times negative 8x. This is an example of two monomials that are being multiplied together. We have the monomial, the variable term negative 2x, multiplied by the other monomial variable term 8x. So what we're going to do is we're going to multiply the coefficients. Negative 2 times 8 is negative 16. And then, because these two variables are the same, we're going to simplify them by adding their exponents. So there's an exponent of 1 there and an exponent of 1 there. So x to the power 1 times x to the power 1 is x to the power 2. So negative 16x squared would be that product. Now remember, that product rule for exponents only works when the variables are the same. So for this next one, we have a lot of monomials that are being multiplied together. We have negative 2x cubed y, and remember, this is all just one giant term, times another monomial, and then times a third. What we're going to do is we are going to multiply this in pieces, because remember, order doesn't matter with multiplication. So you can multiply in any order that you want, and you can group multiplication however you want. So I'm going to first multiply the coefficients together. Negative 2 times negative 4 is positive 8. 8 times 10 is going to give us 80. Then I'm going to multiply the x's together. So I have x to the power 3 times x to the power 2 times x to the power 1. So because all of these variables are the same, and they're all being multiplied together, I'm going to simplify by adding their exponents. So 3 plus 2 gives us 5. 5 plus 1 is x to the power 6. Then I'm going to do the same thing for the y. So I have y to the power 1 here, y to the power 4 here, and then another y to the power 1 here. Because all of these bases are the same and we're multiplying them all together, I'm going to simplify by adding their exponents. So 1 plus 4 is 5, plus 1 is 6. So 80x to the 6th, y to the 6th is going to be our final answer. So we're going to do the same thing for each of these. So for each of these, we're going to multiply these monomials together by multiplying their coefficients. And for any bases that are the same, we are going to combine them by adding their exponents and using the product rule for exponents. So for this first one, we're going to multiply the coefficients first. Negative 3 times positive 2 is negative 6. Then for like bases, we're going to multiply them by adding the power. So I have a to the 4th times a to the power 1. Because these bases are the same and they are being multiplied together, I'm going to simplify by adding their exponents. 4 plus 1 gives us a to the 5th. Then I'm going to do the same thing for the b's. So I have b to the 3rd times b to the 4th. Because these bases are the same and they're being multiplied together, I'm going to simplify by adding their exponents, gives us b to the 7th. So if you haven't yet, I want you guys to try the next one. So I want you to multiply these two monomials together. And remember, you can only combine like bases by adding their powers. So go ahead and pause the video and try the next one. All right, so for this next one, we're going to first multiply the coefficients together. So we have negative 5 times 4, which is negative 20. Then let's multiply the a's together. So I have a to the power 1 times a to the power 5. When we're multiplying them together, gives us a to the power 6. And then we have this b to the 3rd. And there are no other bases of base b. So because this is the only base b, we're going to just leave it alone. Nothing combines with it, but it doesn't go away. So we're just going to leave it on the end like this. So negative 20, a to the 6th, b to the 3rd is going to be our final answer. Now that's how to multiply two monomials together. And what we're going to do throughout this section is we are going to slowly increase the number of terms in each of the polynomials that we're multiplying. So when you multiply a monomial by a polynomial, this will involve you taking a single term, a single monomial, and multiplying it to a polynomial of multiple terms. This is going to involve distribution. So what you're going to do is you're going to distribute that monomial to each of the terms in the polynomial. And then as you multiply each individual terms together, remember that you're going to multiply the coefficients. And if the variables are the same, you're going to add their exponents. Then after you do this, if you have any like terms, you're going to combine them to finish simplifying, if even necessary or possible. And remember, when all you're doing is combining like terms and adding together, like adding terms together, you don't change the exponents. The only time that you ever change exponents on variables is when you multiply variables together, which is this step here. But never add exponents when all you're doing is adding terms together. All right, so we're going to multiply each of these next. So I have the monomial negative 3x squared, and I am multiplying it by the polynomial negative 8x plus 9. So what I'm going to do is I'm going to take this negative 3x squared and I am going to distribute it to every single term in the polynomial. So I'm going to take negative 3x squared and I'm going to multiply it by negative 8x. So when I multiply these terms together, let's multiply the coefficients. Negative 3 times negative 8 will be a positive 24. And then because these two variables are the same, I'm going to simplify by adding their exponents. So x squared times x to the power 1 is x to the power 3. Then I'm going to take this negative 3x squared and I'm going to multiply it by the next term. So because the next term does not have a variable, you're going to leave the variables alone. So you're just going to multiply the coefficients. Negative 3 times 9 is negative 27. And because this term has a variable and this one does not, you're just going to leave the x and its exponent alone. And because these are unlike terms, yes, we have the same variable, but they are two different powers. Because these are unlike terms, this is our final answer. So we're going to do the same thing for this next one. Remember, anything linked with multiplication is all considered one giant term. So this 3p squared times q to the power 1, this is all one giant term because it's all linked with multiplication. And because this term is being multiplied by this polynomial, what we're going to do is we're going to have to distribute that monomial to every single term in the parentheses. And remember, you can only add exponents when the bases are the same. So we're going to take 3p squared q times 5p to the third. So let's multiply the coefficients. 3 times 5 is 15. And I have p squared times p to the third. Those variables are the same, so I'm going to add the powers, p to the fifth. However, because this first term has a q and this one does not, I'm just going to leave q alone. Then I'm going to distribute 3p squared q to the next term. So remember, this 2 is negative because it takes the sign to its left. So positive 3 times negative 2 is negative 6. Then I'm going to combine the exponents on the p. So p to the power 2 times p to the power 1 is p to the power 3. Then I'm going to combine the exponents on q. So q to the power 1 times another q to the power 1 is q to the power 2. Then I'm going to take 3p squared q and multiply it to the last term. So 3 times 1 is positive 3. There is a p in this term, but not in this term, so I'm going to leave the p squared alone. And I'm going to take q to the power 1 times q to the power 3. Those variables are the same, so I'm going to add their exponents, q to the fourth. Now, in this expression, like terms would be the same combination of variables to the same combination of powers. And even though they all have p's and q's, none of these have the same combinations of variables and exponents. So because they are all unlike terms, this is going to be our final answer. So for this next one, remember that multiplication always comes before addition in any order of operations. So this plus sign here in the middle does count as addition. Not only is it making the x squared positive, but it also counts as addition. And I do see some multiplication here. I see this 8x squared times the polynomial 3x plus 1. And then I see the monomial x squared times the polynomial 5x squared minus 6x plus 5. So because multiplication comes before addition in order of operations, what you're going to have to do is do the distributing first, and then after that's done, you're going to tackle the addition and then basically combine like terms. So let's take this 8x squared first, and we're going to multiply it to everything in the parentheses next to it. Now, as soon as these parentheses stop, you stop distributing 8x squared. So if 8x squared times 3x to the power 1, let's multiply the coefficients. 8 times 3 is 24. X to the power 2 times x to the power 1, because these two variables are the same, we're going to add the powers, x to the power 3. Then we're going to take 8x squared times 1. So 8 times 1 is positive 8. And because this has a variable and this does not, you're just going to leave the x squared alone. Then I'm just going to leave that plus sign in the middle where it was, because I'm going to have to do the same thing to this next group. I'm going to have to multiply this monomial by this polynomial first, and then I will tackle the addition. And remember, if you don't see anything in front of the x squared, you can assume there's a positive 1 there, and it's positive because of the plus sign to its left. So I'm going to take 1x squared and I'm going to distribute it to everything in the parentheses next to it. So 1x squared times 5x squared. 1 times 5 is positive 5. And then x squared times x squared, because these variables are the same, we're going to add the powers, gives us x to the fourth. Then we have x squared times negative 6x. So positive 1 times negative 6 is negative 6. And then for x squared times x to the power 1, because these variables are the same, we're going to add the powers, gives us x to the third. Then 1x squared times 5. 1 times 5 is positive 5. And then because this has a variable and this does not, we're going to just leave the x squared alone. So now that we have done that multiplication, now we can add the two polynomials together. And you might remember from the last video, when you add polynomials together, all you have to do is combine like terms. And while we're at it, we're going to write our answer in standard form. We're going to make sure that the exponents are listed from the highest to the lowest. So looking through this, the highest exponent that I see between all of these is this x to the fourth. And because there's no other terms that contain an x to the fourth, I'm just going to list this 5x to the fourth first, and then we're going to move on. Next power down from 4 is x to the power 3. So I have this 24x to the power 3 minus 6x to the power 3. Now remember, like terms are the same variable to the same exponent. So because these are both x to the thirds, I'm going to combine them. Now remember, to combine like terms, all you do is add their coefficients. So 24 plus negative 6 is positive 18. And also remember that when all you're doing is adding terms together, you do not change the variable and you do not change the exponent. The only time you change exponents is when you multiply variables together. So because we're just adding these together, I left the x cubed alone. Next, we're going to go to the next power down from 3, which is 2. And I have a couple of those. I've got this positive 8x squared and this positive 5x squared. So because these both have an x squared on them, I'm going to add them together. 8 plus 5 gives us positive 13. And because we are only adding terms together, I'm going to leave the x squared alone. And that actually covered everything. So now that all of these are unlike terms, now that there are no more like terms, this is now our final answer, and this is now fully simplified. So that was how to multiply a monomial by a polynomial. So now what we're going to do is we're going to slowly increase the number of terms. So for this next part, we're going to be multiplying two binomials together. So what this means is that you are going to be multiplying two polynomials that each contain exactly two terms. So you're going to have two sets of parentheses. And in each set of parentheses, you're going to have two terms that are separated by either a plus sign or a minus sign. And they're going to be unlike terms in each of the parentheses. Now, there is a process for multiplying these. Some of you may have learned the acronym FOIL before, some of you may not. But FOIL is a good acronym that works for two binomials. Now, I do want you guys to also make a note here before we get too much further, is that the acronym FOIL only works when each parenthesis contains exactly two terms. So the acronym FOIL only works when each parenthesis contains exactly two terms. As soon as one of your parentheses do not have two terms, as soon as one of your parentheses has three terms or more terms, FOIL does not work. FOIL only works when each parenthesis contains two terms. And as soon as one or both parentheses contain more than two terms, you throw FOIL out the window. However, because for these two sets of parentheses contain exactly two terms. The first parenthesis contains x and 4. Second parenthesis contains 7x and 2. FOIL is going to work here. So here's how FOIL works. What we're going to do is we're going to multiply the first terms together, the first term in each set of parentheses. So I'm going to multiply this 1x to the power 1 times 7x to the power 1. So let's multiply the coefficients. 1 times 7 is 7. Then, because the variables are the same, we're going to add the powers, 7x to the power 2. Then we're going to multiply the outside terms together. So the outside terms in each parenthesis will be this 1x to the power 1 times 2. So 1 times 2 is positive 2. And because this contains a variable and this does not, we're going to just leave the x alone. Then we're going to multiply the inside terms together. So the inside terms will be this 4 and this 7x. So 4 times 7 is positive 28. And because this has a variable and this does not, we're going to leave the x alone. Then you're going to multiply the last terms together. So positive 4 times positive 2 will give us positive 8. Then after you multiply, before you call it good and circle your final answer, you just need to make sure that if there are any like terms that you combine them. And I am looking at these two middle terms. These middle terms both contain an x to the power 1. So these are considered like terms, so let's combine them. So I'm just going to leave the 7x squared where it is because nothing combined with it. 2x plus 28x will be positive 30x, because remember, if all you're doing is adding terms together, you do not change any exponents. And then I'm going to leave this plus 8 where it is because nothing combined with it. So now that these are all unlike terms, this is now your final answer. So I want you guys to try it for yourselves. I want you guys to multiply the binomial 3x plus 1 by the other binomial 5x minus 2. So go ahead and pause the video and resume when you are done working. Okay, so for these next two, what we're going to do is we're going to start with the first terms in each set of parentheses. So we're going to take 3x to the power 1 and multiply it by 5x to the power 1. So 3 times 5 will give us 15. And because these two variables are the same, we are going to add their exponents, gives us x to the power 2. Then we're going to take 3x and multiply it by negative 2 for the outside terms. Remember, a number takes the sign to its left, so yes, this 2 is negative. So 3 times negative 2 will give us negative 6, and because this has a variable and this does not, you're just going to leave the x alone. Then we're going to multiply the inside terms together, so we'll have positive 1 times 5x. 1 times 5 is positive 5, and because this has a variable and this does not, you're going to leave the x alone. And then for the last terms, you're going to multiply positive 1 times negative 2, which is negative 2. And then you're going to look for any like terms. It does look like we can combine the middle terms. So negative 6x plus 5x is negative 1x. And then I'm going to leave the 15x squared alone because it had no like terms. And I'm going to leave the minus 2 alone because it had no like terms. So then this is going to be our final answer. And I will say that the best way to master this is to just do a whole bunch of them. So for this next one, we're going to multiply the binomial 8x minus 3 by the binomial 2x minus 1. So we're going to multiply the first terms together. 8x to the power 1 times 2x to the power 1 will give us 16x to the power 2 when you add the powers. Then for 8x times negative 1, 8 times negative 1 is negative 8. And because this has a variable and this does not, we're going to leave the x alone. Then multiply the inside terms. Negative 3 times 2x is negative 6, and you're going to leave the x alone. Then multiply the last terms. Negative 3 times negative 1 will give us positive 3. Now, I will say that in binomials like this, a lot of times you can combine the middle terms, but don't always expect to be able to do that. So I'm going to leave the 16x squared alone, and then these two terms are like terms, so negative 8 plus negative 6 is negative 14x, and then you're going to leave the plus 3. So then for this last one, remember that when you have multiple variables, the only time that you can add exponents is when the variables are the same and you are multiplying them together. If you are multiplying unlike bases together, you just put them together with multiplication, you don't add their powers, and you just basically write them next to each other and move on. So keep that in mind when we multiply these next two binomials. So we have the binomial 3a plus b times the binomial 2a minus b. Because each of these parentheses contains exactly two terms, we can still use the FOIL acronym here. We just have to be careful about what exponents we do and do not add together. So we're going to multiply the first terms together, 3a to the power 1 times 2a to the power 1. Well, 3 times 2 will give us 6. And then a to the power 1 times a to the power 1. Because these two variables are the same, we can combine them by adding their exponents. So a times a will give us a squared. Then we're going to move on to the outside terms. So we have 3a times negative 1b. So positive 3 times negative 1 is negative 3. However, a and b, these are not the same variable. So because these two bases are not the same, you can't add their powers. But what we can do is we can just write them together with multiplication. So this will give us negative 3ab. And that's it. Then we're going to move on to the inside terms. So we have positive 1b times positive 2a. So 1 times 2 is positive 2. And then we have b times a. Once again, the variables are not the same. So when the bases are not the same, you cannot add their powers. Also, b times a, remember, order doesn't matter with multiplication. So b times a is the exact same as a times b. And for consistency, I'm going to write it as 2ab. Just to keep it consistent. Then when you multiply the last terms, I have positive 1b times negative 1b. So positive 1 times negative 1 is negative 1. b times b. Now that these two variables are the same, now we can combine them by adding their exponents. So b times b will give us b squared. And then for combining like terms would be the same combination of variables to the same combination of powers. So for 6a squared, there are no other terms that contain just an a squared, so you're just going to leave 6a squared alone. However, the two middle terms are like terms. We have negative 3ab plus 2ab. Because these two terms contain an a to the power 1 and a b to the power 1, they are considered like terms. So when you combine like terms, you're just going to add the numbers in front. So negative 3 plus 2 is negative 1ab. Then for the minus b squared, there are no other terms that just contain a b squared, so there's nothing like with that. And when you are left with only unlike terms, that is now your fully simplified final answer. So I want you guys to try these two for yourselves. Remember that a number always takes the sign to its immediate left, so be very careful with your negatives here. But I want you guys to use the acronym FOIL to multiply these two binomials, these two pairs of binomials together, and make sure that your answer is fully simplified. So go ahead and pause the video and then resume when you are done working. All right, so for this next one, we're going to multiply the first terms together. This is a negative 3x to the power 1 times 1x to the power 1. So negative 3 times positive 1 is negative 3. X times x, because the variables are the same, we're going to add their powers, x to the power 2. Then negative 3x times 2. So negative 3 times positive 2 will give us negative 6. Because that has an x and that does not, you're just going to leave the x alone. Then multiply the inside terms. This one is negative, so we have negative 1 times 1x is negative 1x. You can have the 1 there if you want to, not necessary, not required. And then multiplying the last terms together. Negative 1 times positive 2 is going to give us negative 2. Then you're going to look for like terms that you can combine. Looks like we can combine the middle terms. So I'm going to leave the negative 3x squared alone, and I'm just going to add the middle terms together. So negative 6 plus negative 1 is negative 7x. Then you're going to leave the minus 2 alone, and then that will be your final answer. So then looking at this next one, we have negative 1x minus 4 times 3 plus 1x. So let's start by multiplying the first terms together. So we have negative 1x times 3. So negative 1 times 3 is negative 3. Because that has a variable and that does not, you're going to leave the x alone. Then you're going to multiply the outside terms. So negative 1x times positive 1x. So negative 1 times positive 1 is negative 1. And then x to the power 1 times x to the power 1. Because these two variables are the same, we're going to combine them by adding their powers. So this will be minus 1x squared. Then multiplying the inside terms. Negative 4 times 3 is negative 12. Sorry about that, negative 12. And then for the last terms, we have negative 4 times 1x. Negative 4 times positive 1 is negative 4. Because this has a variable and this does not, you're going to leave the variable alone. So then from here, what you will do is we're going to do a couple of things. We're going to make sure that this final answer of ours is in standard form. So we're going to make sure that the highest exponent is first and that the exponents decrease. And we're going to combine like terms. So the highest exponent that appears is 2, and the term is negative x squared. So I'm going to list that first. Next power down from 2 is an exponent of 1, and I have a couple of those. So I have this negative 3x to the power 1 minus 4x to the power 1. And when you add them together, negative 3 plus negative 4 is negative 7x. And remember, you do not change any variables or powers when all you're doing is adding together. And then this minus 12, there are no other terms that contain, no variable. So this minus 12 is just going to be on the end here, and then this is going to be your final answer. Now remember, as soon as one of those parentheses contains more than 2 terms, you throw FOIL out the window. FOIL does not work if one of the polynomials that you're multiplying has 3 or more terms. So for this next group, we're not going to be using FOIL, but we are going to be using the same idea as FOIL. So if you go back to, let's say here, when you multiply the first terms and the outer terms, what you're basically doing is you're taking the first term in the first polynomial and first distributing it to every single term in the second polynomial. Then for the inside terms and the last terms, you're taking the second term in the first polynomial and multiplying it or distributing it to every term in the second polynomial. That's going to be the same basic idea when you are multiplying polynomials with more than 2 terms together. What you're going to do is you're going to take each term in the first polynomial, one at a time. And you're going to distribute each term one at a time to every single term in the second polynomial. Just remember, multiply the coefficients, and if the variables are the same, you're going to add their exponents. So in a case like this, do not use FOIL. Do not use this. FOIL's out the window because the first polynomial has 3 terms. However, we're going to use the same spirit of FOIL, so we're going to take the first term in the first polynomial, and we're going to distribute it to every single term in the second polynomial. And then once we have distributed x squared to every single term in the second set of parentheses, then we can move on to the 3x, and then we can move on to the negative 1. So we're going to take 1x squared and we're going to multiply it to every single term in the second polynomial. So 1 times 1 is positive 1. X squared times x to the power 1, because those two bases are the same, we're going to add their exponents, gives us x to the power 3. Then we're going to take x squared and multiply it by 2. So 1 times 2 is positive 2. Because this has a variable and this does not, you're going to leave the x squared alone. So now that we've multiplied that x squared to every term in the second polynomial, then we're going to move on to the plus 3x. So now we're going to take 3x and multiply and distribute it to every single term in the second polynomial. So then you're going to take 3x and multiply it by 1x. So 3 times 1 is positive 3. X times x, because the variables are the same, you're going to add the powers, gives us x to the power 2. Then you're going to take 3x and multiply it by 2. So 3 times 2 is positive 6. Because this has a variable and this does not, you're going to leave the variable alone. Now that we've distributed 3x to every term in the second parentheses, now we are going to move on to the negative 1. So now we're going to take negative 1 and distribute it to every term in the second parentheses. So negative 1 times 1x is negative 1, leave the x alone. And then negative 1 times positive 2 is negative 2. So now that you've distributed, now you're going to combine like terms. So it does look like the exponents are in the order from highest to lowest. We don't have to worry about that. Nothing combines with x cubed, so I'm going to leave it alone. But the x squared terms can be put together. So 2x squared plus 3x squared is positive 5x squared. And then also the x terms can be combined. So positive 6 plus negative 1 is positive 5x. And then you're going to leave the minus 2 alone. And now that you are left with only unlike terms, this is now fully simplified. So that's going to be the same basic idea. So this next one looks very similar, so I want you guys to try it. Remember, you're not going to use FOIL. What you're going to do here is you're going to multiply every single term in that first set of parentheses one at a time and distribute them one at a time to every single term in the second set of parentheses. So go ahead and pause the video, try this one out, and resume the video when you're ready to check your answer. All right, so the first term is 3y squared. So we're going to take 3y squared and we're going to multiply it to every single term in the second parentheses. So 3y squared times 4y is going to give us 12y, add the powers to the third power. And then 3y squared times negative 1 will give us negative 3, leave the y squared alone. Then we're going to take this plus 1y and we're going to distribute it to everything in the second set of parentheses. So 1 times 4 is positive 4. Y times y, because the variables are the same, we're going to add the powers, y to the power 2. Then 1y times negative 1 is negative 1y. Now that we've distributed y to every term in the second parentheses, now we're going to move on to this last term 5, and we're going to distribute it to every single term in the second parentheses. So 5 times 4 will give us positive 20, and you're going to leave the y alone. And then 5 times negative 1 will give us negative 5. So from here, we're just going to double check to see if this is vaguely in standard form. We have exponent of 3, 2, 1, and a constant, so the exponents are in order. So let's go combining like terms. So nothing combines with this 12y cubed because there's no other term that contains a y cubed. However, the y squareds can be combined. So we have negative 3y squared plus 4y squared is going to be positive 1y squared. And then we can combine the y terms together. So we have negative 1y plus 20y is going to give us positive 19y. And because there are no other constant terms that don't have a variable, we're just going to leave that minus 5 alone. And then this is going to be our final answer. So let's try a couple more of those. So we're going to take the polynomial 4x cubed minus 2x plus 1 and multiply it by the polynomial x plus 5. And remember, because the first set of parentheses contains more than 2 terms, we are not going to use FOIL. What we're going to do is we're going to take each term one at a time in the first set of parentheses and distribute them to every single term in the second set of parentheses. So we have this 4x cubed times 1x to the power 1. 4 times 1 is positive 4. X cubed times x, because the variables are the same, we're going to add the powers, x to the power 4. Then we're going to take 4x cubed, multiply it by 5. 4 times 5 is positive 20. Because this contains a variable and this does not, we're going to leave the x cubed alone. Then we're going to take negative 2x and then do the same thing. I'm going to take negative 2x and distribute it to every single term in the second parentheses. So negative 2x times positive 1x is going to give us negative 2. Because the variables are the same, we're going to add the powers, x squared. And then negative 2x times positive 5 is going to give us negative 10. Leave the x alone. Then we're going to take this positive 1 and we're going to distribute it to every single term in the second parentheses. So 1 times x is positive 1x, and then 1 times 5 will give us positive 5. And now from here, what we're going to do is we are going to try combining like terms. The exponents are decreasing, so 4, 3, 2, 1, and a constant. So let's just combine like terms. So nothing else contains an x to the fourth, so there's no like terms with this 4x to the fourth. And then same thing for this x cubed. There's no other terms that contain an x cubed, so you're just going to leave 20x cubed where it is. And unfortunately, same thing with this negative 2x squared. There are no other terms that contain an x squared, so you're just going to leave that minus 2x squared alone. However, the x terms can combine, so we have this negative 10x plus positive 1x will give us negative 9x. And then nothing else combines with that plus 5, so you're going to leave it alone, and then this is your final answer. Now this next one is going to be the same idea. The distribution part is going to be the exact same. The big difference is that you can only add exponents when the variables are the same. If the variables are not the same, you're just going to smush them together with multiplication and call it good. So I'm going to take this positive 1a squared and I'm going to multiply it to every single term in the second set of parentheses, keeping in mind that you can only add powers when the variables are the same. So we have a squared times a. 1 times 1 is positive 1. And because these variables are the same, I'm going to add the powers, a cubed. However, when you multiply a squared times b, because these variables are not the same, you're just going to put them together with multiplication. A squared b, you cannot add the exponents, and that's as good as that's going to get. Then you're going to take this positive 2ab and do the same thing. Anytime that you're multiplying a's together, you add their powers. Anytime you multiply b's together, you add their powers. So positive 2ab times 1a is going to be positive 2. All right, so a times a, we're going to add the powers, is going to give us a squared. However, because this contains a b and this doesn't, you're just going to leave the b alone. Then you're going to take 2ab and multiply it by b. So 2 times 1 is positive 2. This contains an a and this does not, so you're going to leave the a alone. However, b times b, these are like bases, so because these two variables are the same, we're going to add the powers on b to give us b squared. Then we're going to take this positive 1b squared and we're going to multiply it to every single term in the second parentheses. So b squared times a, these are not the same variables, so we can't add the exponents, but what we can do is just put them together with multiplication. Also, b squared times a is the same as a times b squared, and just to keep it consistent, I'm going to leave it as plus ab squared. And then b squared times b, these two variables are the same, so I'm going to add their powers, b to the third. So then from here, we're going to combine like terms. And I'm not going to make a huge deal about standard form here. This is technically in standard form, so we're just going to leave it. However, I am going to combine like terms. Now, like terms would be the same combination of variables to the same combination of powers. So for this a cubed, a like term with this would be another term that contains an a cubed. There are none, so I'm just going to leave a cubed alone. Then for the next one, a like term with a squared b would be another term that has both an a squared and a b to the power 1, which is this term right next to it. So 1 plus 2 will give us plus 3 a squared b. Remember, when you're adding terms together, don't change any variables or exponents. Then for this next one, for this plus 2ab squared, a like term would be another term that has both an a to the power 1 and a b to the power 2, which is this term right next to it. So 2 plus 1 will give us positive 3ab squared. Then for this b cubed, a like term would be another term that contains only a b cubed, which since there aren't any, I'm just going to leave b cubed alone. And then this is technically our final answer. I'm not going to make a big deal about standard form when you have more than one variable. This is technically in standard form because the a's exponents are decreasing while the b's exponents are increasing. Don't worry too much about that. I was just more focusing on when do you add exponents and what are considered like terms. That was the goal of this example. Now, on the same vein of multiplying polynomials, we will have some what are called special products. So we started this chapter with exponents because you have to remember that exponents are repeated multiplication. So if you square a number, that is the same as multiplying it by itself. Now, if you take a polynomial and you square it, it's going to be the same idea. If you were squaring a polynomial, that is going to be the same as multiplying the polynomial by itself. So this a plus b squared here is an example of a polynomial that is being squared. You're going to take the polynomial a plus b, and the parentheses indicate that everything in the parentheses is all getting squared. You cannot distribute a power across a plus sign or a minus sign. We went over this in the 10.1 to 10.2 video, in the very first video in this course. This is not equal to a squared plus b squared. Do not distribute an exponent across a plus sign or a minus sign. If you do this, you get absolutely no credit on any homework question or any exam question. Here's what you do instead. Remember that squaring is the same as multiplying it by itself. So what I'm going to do is I am going to actually take this exponent and I'm going to write it as repeated multiplication. And this is a process called expanding. So everything in the parentheses is getting squared. So I'm going to rewrite this as a plus b times itself a plus b with parentheses around both of them. Now that you've written it as repeated multiplication, this should look familiar. This is multiplying two, they're identical, but you're basically multiplying two binomials together. You need to distribute this. So a times a will give us a squared. A times b just can be written as ab. And then for the inside terms, b times a is the same as a times b. And then b times b is b squared. So then when you combine the two middle terms, you get a squared plus 2ab plus b squared. That is how you square a polynomial. So to multiply either of these, what you have to do is you have to expand them first and then multiply using distribution. So this x plus 7 squared is not going to be x squared plus 49. Don't do this. Exponents and addition are too far removed in order of operations for you to distribute a power across a plus sign or a minus sign. So don't do this. What you have to do for x plus 7 squared is you have to expand it first, which means writing it as repeated multiplication. X plus 7 times itself, x plus 7. Then, once you have it expanded, then you can multiply it using distribution. So x times x will give us x squared. X times 7 is plus 7x. 7 times x is another plus 7x. And then 7 times 7 gives us positive 49. Then you're going to combine the terms in the middle. So combine 7x plus 7x gives us plus 14x, and then plus 49. So that is going to be the general idea any time that you have a polynomial that is being squared. So I want you guys to try it for this next one. I want you to expand this out first and then multiply it using FOIL, and remember that you can only add the exponents when the variables are the same. So go ahead and pause the video, work through this one, and then resume when you're ready to check your answer. All right, so for this next one, I am going to expand this exponent first by writing it as repeated multiplication, 2x plus 3y. times itself 2x plus 3y. Note the parentheses around each of them. Then I am going to distribute. So 2x times 2x will be 4x squared. 2x times 3y will be positive 6. And because these two variables are not the same, you just write it as xy, and that's it. Then multiplying the inside terms, 3y times 2x is positive 6. Now y times x is the same as x times y, and just for consistency, I'm going to write it as x times y. And then 3y times 3y will give us positive 9y squared. Like terms of the same combination of variables to the same combination of powers. So 6xy plus 6xy, you can combine those to 12xy. And unfortunately, nothing combines with 4x squared and nothing combines with 9y squared, so then this is going to be your final answer. The same thing is going to apply even if you have a minus sign between your terms instead of a plus sign. You cannot distribute an exponent across a plus sign or a minus sign, so this is not the same as a squared minus b squared. What you need to do is, just like before, you need to expand it by writing it as repeated multiplication first, and then multiply them using distribution. So then this will be a times a, which will be a squared. A times negative b will be negative ab. Negative b times a is another negative ab. And then negative b times negative b is positive b squared. Then you're going to just add the middle terms together, so negative 1ab plus another negative 1ab will give us negative 2ab, and then plus b squared. So yes, do not distribute a power across a plus sign or a minus sign. Make sure that you expand it first and then distribute. So these two are the exact same idea. I want you guys to pause the video and expand and multiply these two. Same idea as before. All right, so for this 8a minus 1 squared, we're going to expand out the exponent by writing it as repeated multiplication. So we're going to write it as 8a minus 1 times another 8a minus 1. Now that we've expanded it, we're going to then simplify this by distributing. So 8a times 8a is going to be 16. Add the powers, a squared. Then 8a times negative 1, positive 8 times negative 1 is negative 8. Because this has a variable and this does not, you're going to leave the a alone. Then for the inside terms, we have negative 1 times 8a is going to give us negative 8, and you're going to leave the a alone. Then negative 1 times negative 1 will give us positive 1. The only like terms here are the middle terms, so we're going to just add those together. So negative 8a plus negative 8a is negative 16a. And then this is going to be your final answer. So then for the next one, it's going to be the same idea. You cannot distribute a power across a plus sign or a minus sign. So what you're going to do is you're going to expand this out first. So this will be 3a minus 4b times another 3a minus 4b. Now that we've expanded this, now we're going to multiply. So we have 3a times 3a will be 9. Add the powers, a squared. However, when you multiply 3a times negative 4b, you'll get negative 12. A and b are different variables, so you're just going to smush them together with multiplication and call it good. Negative 12ab. Then for the inside terms, negative 4 times 3 is negative 12. B times a, again, you can't add the powers, but you can keep it consistent and write it as a times b. And then for negative 4b times another negative 4b will be a positive 16. And then because these variables are the same, you can add the powers, b squared. Like terms are the same combination of variables to the same combination of powers. So the only like terms here are the two in the middle. Negative 12ab plus another negative 12ab is negative 24ab, and then plus 16b squared. So then for this last group is another special type of product, and this one's going to be a little bit different. So what we're going to do is we know how to multiply each of these. We know how to FOIL, we know how to distribute, but what we're going to do for each of these is as we multiply these, you're going to notice something happening with the middle terms pretty much consistently. And what I want you guys to do is as we go, I want you guys to try and figure out why this is happening. What about the original polynomials is causing this to happen with the middle terms? So for this first one, I'm going to multiply x plus 5 times x minus 5. So let's multiply. We have x times x, which is x squared. X times negative 5 is negative 5x. 5 times x is positive 5x. And then positive 5 times negative 5 is negative 25. Now, when you combine the middle terms, what do negative 5x and positive 5x add up to? Negative 5 plus 5 adds up to 0. And 0 times anything is 0. So, 0 times x is just equal to 0. And since adding 0 doesn't do anything, what happens is when you have terms that add up to 0, they just cancel out, leaving you with x squared minus 25. So you can see why this is considered a special product. And I will say that everything on this slide is a special product, and we're going to go through the multiplication, and we're going to see what about the original polynomials is causing the middle terms to consistently cancel out. So for this next one, for x plus 3 times x minus 3, we're going to multiply these. So x times x will give us x squared. X times negative 3 is negative 3x. 3 times x is positive 3x. And then 3 times negative 3 is negative 9. When you combine the middle terms, negative 3 plus 3 gives us 0x, which leaves us with x squared minus 9. So what about the original polynomials is causing this to happen? If you look at the original polynomials, the original binomials in each of the parentheses, you will notice that they are almost identical except the sign in the middle. So we have x plus 5, x minus 5. Again, the two parentheses are almost identical except for these signs. They're different. Same thing here, x plus 3, x minus 3. They're the exact same except for the sign in the middle. That is what is causing the middle terms to cancel out. And anytime that this happens, anytime your two binomials are exactly the same except for the sign in the middle, when you multiply them together, you get what is called a difference of squares. So x squared minus 25 is a difference of squares because difference means subtraction. Squares mean a subtraction of two perfect squares. So x squared is a perfect square and 25 is also a perfect square. So because we are subtracting two perfect squares, that is called a difference of squares. X squared minus 9 is another example of a difference of squares. And differences of squares happen when you have multiplied two polynomials that are almost identical except for the sign between them. So we're going to go through each of these and we're going to see if that applies for each of these. So for p minus q times p plus q. These two parentheses are almost the exact same except for the sign in the middle. And it really doesn't matter if the plus goes first or if the minus goes first, because remember, order doesn't matter with multiplication. So because the two signs are opposites and the binomials are otherwise identical, this is going to give us another difference of squares. P times p will give us p squared. The middle terms will cancel out, and then negative q times q will be minus q squared. Same thing for this next one. We have 3m plus 2n times 3m minus 2n. Because these parentheses, 3m and 3m, are the same, 2n and 2n are the same, the only difference between these two binomials is the sign between them. So when the only difference between the two binomials is the sign between them, it's going to give you a difference of squares. So 3m times 3m will be 9m squared. Middle terms will cancel out, and then 2n times negative 2n will be negative 4n squared. And that will happen no matter what is in those binomials. As long as the binomials are exactly the same except for the sign between them, you're going to end up with a difference of squares. So for this next one, we have 3a squared, exactly the same. 5 and 5, exactly the same. The only difference is the sign between them. So when that happens, the middle terms are always going to cancel out. So you'll have 3a squared times 3a squared, which is 9, a to the fourth, because you add the powers. 15a squared and negative 15a squared will cancel out when the middle terms cancel out. And then negative 5 times positive 5 will be minus 25. So when you're multiplying two binomials and the two binomials are identical in every way except for the sign between them, the middle terms will always cancel out. Just be very careful of this, because if there is even a slight difference, such as 3m plus 2n times 2m minus 2n, if there is a slight difference in any of the terms, this will not happen. So in this type of scenario, the middle terms are not going to cancel out because these first terms are different. So in that case, you'll have to go through the full distributing process, combining like terms, and the middle terms will not cancel out. So that is it for multiplying polynomials and special products. So that is going to be it for sections 10.5 and 10.6. In the next video, we are going to be covering how to divide two polynomials in a process called polynomial long division. So thank you all very much for watching, and I will see you in the next video. Bye-bye.